everyone! We have all learned that electrons spin around the nucleus in their own special orbits, right? But here is the mind-bending mystery. Why electrons don't just change their orbit whenever they feel like it? And the interesting thing here is that this is not just a bookish question, but also an answer for fireworks function, neon sign, and even the colors in the night sky. Today we are going to uncover the three secrets of how electrons stick to their orbits, and the third one is a strict reason. Ready to get to the bottom of this? Let us start with the basics. Atoms are made up of three tiny particles: protons, neutrons, and electrons. The protons and neutrons live in the nucleus at the center, while the electrons orbit the nucleus in specific paths or energy levels. But here is the catch: they can't just orbit anywhere because these paths of electrons are quantized. Think of them like rungs on a ladder. The electron has to be on one rung or another, not in between. So why don't electrons move up or down these rungs at will? It's all about minimizing energy. The electron tries to remain in the nearest unfilled orbit to the nucleus because they naturally prefer the lowest energy state called the ground state. For an electron to jump to a higher orbit, it needs to absorb exactly the right amount of energy. And to drop to a lower orbit, it has to release that same precise amount. For example, if a photon, a particle of light, comes along with just the right energy, the electron can absorb it and move to a higher orbit. When an electron drops back down into a lower energy state, it releases that energy as a light. That's how fireworks, neon signs, and even the colors in the night sky work. Amazing, right? But what if the photon's energy doesn't match perfectly? The electron simply ignores it, like a picky dinner turning down the wrong dish. Now, let us take it a step further. Electrons aren't just tiny particles, they are also waves described by something called wave function. In simple terms, wave functions define the probability of where an electron can be found in a certain positions or states. It is represented by the symbol psi. Each orbit corresponds to a specific wave pattern, and jumping between orbits means completely changing that pattern. This takes energy and follows strict quantum rules. And don't forget about other laws of physics. Every electron transition must follow the laws of conservation like energy and angular momentum. If the conditions aren't perfect, the electron just doesn't move. It's like that for living in a school. Consent of your class teacher, school principal, parents, and also grandparents are required. So why don't electrons move to another orbit? Let us recap. The first reason is they prefer the stability of the ground state. The second reason is they need a very specific amount of energy to move. And the third reason is their wave-like nature makes their orbits fixed and quantized, and it must go along with energy conservation law. Hence, it's not magic, it's a quantum mechanics that keeps everything in order. Thanks for joining me on this quantum journey. If you learned something new today, give this video a thumbs up, hit subscribe, and drop your question in the comments. Let us keep exploring the universe, one atom at a time. See you next time.